And now to the first speaker. It's a smooth transition because, yes, she is also a member of the VDSG board, so very smooth here. Iveta Lohovska, and yeah, a lot of experience working for HP. She will be much better in introducing herself than I am. So, applause to you. Thanks a lot.
Okay. And I also need to take a selfie, and I will tell you why in a bit. Thank you. It's my third country for today. I woke up in Barcelona, had a meeting in Zurich at the airport just this morning, and landed here for for the conference, because when Francesca asks for something, we all do that, okay? I know you're her student. Yeah. So, let's see if this is working. Is it working?
Yeah. You have to change.
Thank you for the IT support.
Yeah, let's see if I can do it.
Okay,
I think it's you, Iveta.
Yeah. My name is Iveta Lohovska, and I'm the Chief Technology Officer and Chief Scientist of our HPC and AI global team. And HPC stands for Supercomputing. I will try to walk you through, elevate the conversation, show you what is out there in the AI space, and what are some of the cool projects, but also some geopolitical dynamics. Maybe you take it as an investment advice, okay? So, that we are on the same page of what is sovereignty within AI, and I'm myself mathematician, lightweight mathematician at this point, too much traveling, but some things in my work and in my daily life as a scientist who needs to land very heavy algorithms on top of large-scale systems, some things we'd never think of when coming top-down. Energy, there is no AI without energy, and currently most of the algorithms basically consume most of the energy out there. So when I travel around the world, because I'm global, I'm not related to Austria, in the business lounge, just now, they're not only business people and AI people, and I talk to those people. There are a lot of plumbers and energy people, because all of this is liquid cool. So energy, scale, governance, compute, data, talent, I will touch on some of those, but this is the type of the nature of work and project I do. Even though it's AI work, you can't imagine that it's just 5% of the overall picture. Now, sovereign AI, HPC, and the key ingredients that I walk you through. Talent, governance, and network, and I will show you an example of each of those, but let's start with supercomputing and why supercomputing is related to AI. Why I'm talking about this, I work for a company building the most powerful supercomputers. All those supercomputers are used mainly for AI or a mixture of HPC and AI. HPC are traditional simulations, which are still algorithms, just smaller algorithms that junk things in smaller bytes. And this is what currently runs 50 to 60% of the AI operations globally. This is not just the first, the second, and the third exascale supercomputers, so that you have an overview. I had the pleasure to work on Lumi, which is one of the fastest supercomputers in the Nordics, where, how many of you know about Silo AI? Have you heard of Silo AI? No? Have you heard of OpenAI? So Silo AI is the OpenAI of the Nordics. They have trained Viking, Europa, and all of the Nordic languages on Lumi together with my team as an example. Aleph Alpha is the German version of OpenAI. They have trained on their private supercomputer, also on the Swiss one, Swiss national supercomputer, as an example. And my work is to land those algorithms on those machines in parallel. So why am I talking about supercomputers and how is this related to AI? Just to bring you to the AI topic. Pre-deep learning era, everything that you are doing here right now on your laptop, on your telephone, on CSV files and small linear algebra can run on an iPhone right now. Everything post those type of algorithms, for example, deep learning, machine learning, computer vision, you need a server with a GPU. If you want to do more than that, for example, the previous talks were all about GPUs and, they were all about algorithms and statistics and so on, but if you actually do foundational models, you really cannot escape a parallel system of multiple computing environments connected together that run those. So if you do foundational models like we do, training all of the most powerful super models out there, then you need 1 week of the frontier supercomputer at least to just get started. And those are very expensive, very fancy systems. So you could imagine, and you already read the news, the amount of resources you need to actually compete in the AI game. And if you reach 10 to the power of 25, and we have a lot of people like Francesco working for or advising the European Commission, advising the AI Act, then you reach regulation levels. Currently, there are not such computing farms in Europe. I would say also not in the US, maybe trying to get there, but the moment you reach 10 to the power of 25, you have to report to the authorities. But we are getting there, because my work is to build those systems. So I can tell you we are getting there. Is it going to move the needle with foundational models? I don't know. Okay, so I'm sure you already know most of the high-level conversations, definitions, and topics around AI. I will give you the definition of the experts community and what we fight over, what we agree on, and what we disagree on. Artificial narrow intelligence, you know it, you're doing it. If you study here, a master, a single algorithm focusing on a single thing and getting much better than humans. That's solved, I park it there. What we disagree on is, are foundational models AGI or not? You ask different people, you get different answers. I also change my mind from time to time, but it's really combination of single tasks in sequence that's more related to humans' behavior, executed at proficiency level. And now the new term that's still on papers, and I will show you a concrete example, and now you would know why I'm bringing this up, is artificial superintelligence. Remember that, because I will give you examples on what has currently been trained on all of those supercomputers I showed you, and I can tell you it's not agents, because if there are any mathematicians here, you would know that agents will never work because of out of distribution learning. So whatever you see online of a fancy graph showing you agents, especially multi-agent systems, don't waste your time. I will show you what those supercomputers are actually training so that you pay attention on those things. So have we reached artificial general intelligence? As I said, I keep changing my mind. Either Ezra Lutkovsky or Elon Musk or whoever you listen to, you wake up one morning and there's some progress and maybe you change your mind. I have my definition, some mediocre LLM trained on 10 to the power of 30 tokens, which is approximately this amount of word. I have Googled this stuff, just that you know, ever-reaching. And then each token is 2 bytes. You have 20 to the power of 13 volume. So what does it mean? That even the basic LLMs have read most that could be read out there, more than I could ever in my life. Even if I do 3 masters at the Central European University, I would never be able to read that much. So we could say that bucket of data has been exhausted, and LLMs have seen it all, has seen more than you would ever see in your life or you could read. But I can argue that this area of data we have exhausted, I see what my scientists are training on the computers, and it's not anymore text. We have eaten that up. Now, if I take my 4-year-old toddler who cannot read, but he touches things and sees things and smells things and hears things, this is also data. It's just different modality of data. So what we are currently cracking are numbers around different modalities. So 1,600 awake hours of a 4-year-old toddler who cannot read again, but in more modalities, with, again, Googling 2 million optical nerves, fibers, carrying, has seen more data than an LLM at age of 4. So really depends, but I don't think we are nowhere near AGI, and there are a bulk of data sources that are other modalities than text that we are currently focusing on. And again, not agents. Some facts. And again, I cannot keep up with updating my slides. I have tried my best, but some old news here. Calling this as big as the internet, we can have a debate. We can discuss this after this presentation at the networking cafe. I don't think it's a hype, and I think AI and Gen AI and getting into superintelligence is as big as the internet revolution. On the background, oh, maybe I already told you, you see an image. Do you know what this image is? Anyone? You can say it.
I think it won a competition against like, the best artist, and it was crystal clear.
Correct. One of the fanciest art competitions won by AI. No one knew it's made by AI, and of course, you know, artists and designers are very sensitive people, and they like to be appreciated for the art they do. And especially comes some nerd with coding skills and wins their competition with an AI model. That's not fun, but this keeps happening over and over again. So what my point here is that we are taking chunks of human behavior and skills that are supposed to be linked only to humans and now part of algorithms. Universities banning AI. My company tries to ban AI. TEU tries to ban AI. I did study at the TEU and other university around the world. That's a lost cause, and I will give you an example why. The regulations. Some people that EU is not doing great. I would say it's better than many other regions, and you will see why. And how many of you know what Hugging Face is? Perfect. You're the most informed audience I see out there. So Hugging Face is a French startup with 100 people, no revenue, and no plans to make revenue. A year ago, they were evaluated at 4.5 billion. A company of 100 people, no revenue, and no plans to make revenues. Make your ideas of, is this a hype, is this not a hype? But I can tell you, I had a startup, and venture capitals are not generous people. They don't just give you money for the sake of waiting and seeing if things will happen. Even your example. How many of you know Ilya Sutskever, the chief scientist of OpenAI who left? He left a couple of months already ago. The first month when he founded his company, he was one person, one slide, no product, no idea, and no team. And he got 5 billion to build a startup, even not on a slide. So if the Hugging Face example was shocking to you out of Europe, this is another one that should give you some ideas. Now about talent, because I'm based in Europe, and I'm very European. Everyone comes around and tells me on my projects that we don't have talent, and we, not you, because you're the talent in this case, but high-level people. That's the reason that they cannot compete as companies or enterprises or universities out there. So where is the talent then? Is it in the US? Do you need to stay and look for a job here? Do you need to go to the US and look there? Do you need to go to the Middle East or Asia? As I said, I'm a fake mathematician or wannabe mathematician. And the way I check of where the AI talent is, and is it in Europe and is it escaping, is by looking into the International Math Olympics. Because I did compete in the International Math Olympics as a student. I was like, but did I compete with China or US or Russia or South Korea? I competed with Hungary. So when I normalize this for a population and GDP, then Hungary, Romania, and Bulgaria are in the top 3 mathematicians in the world. So those countries are all in Europe. And you all know that because most of you come from those countries. Poland as well, amazing talent. So there's no shortage of talent. Europe just has a tendency to build papers, not startups, and compete, to have a nice lifestyle, not like my lifestyle, to be in 3 countries in one day. But it's an example of how much talent is out there that we are not currently utilizing. One of the most powerful models right now out there is the GPT-5, the full package, the Pro, and it does a very good reasoning on the International Math Olympics, code generation, and code translation. If this is the most powerful model, who created this behind the curtain of OpenAI? Any guesses? No? 80% of the science team of OpenAI is Polish. And this is another argument of people grown up in Poland and went to the normal technical university within Poland, created the most powerful model out there, but not only the model, the whole revolution around Gen AI. So if there are any Polish people, just feel better now. Okay, governance. I will make 3 arguments. Total job transformation. I will give an example with myself. Open source drives innovation. You had some great speakers and open source contributors. Everything that you do or you recommend others doing, please make it open source. And I will give you an example on symbiotic collaborationships. Partner with big and small, with students and professors, because it's too difficult to keep up with this industry, and there is no one person who knows it all. So total job transformation, I'm, as I said again, trained mathematician, not a programmer. My job was to write my algorithms into Python and R, and I'm the worst in that. I'm a very sloppy programmer. I can't do that. I did, and we had conversations, do I need to learn to code or not? I spent 4 years Technical University Sofia in Bulgaria, 2 years in the US, 4 years at the TU here, and I hated that. Because if you have to code, you know how horrible of a thing is if you're not a programmer and more of an applied scientist. So now it takes me 7 minutes and 12 prompts to pull out any algorithm. I don't have to understand that. And I ask, I want the code in Python. It's perfect, much better than I would ever do it for my 10 years of trying to learn how to code. And then I say, oh, can you translate this into R so I can plug it here? And it takes me less than 12 minutes. So I don't know if you should learn coding. If you go in healthcare and life science, I prefer that you as a doctor know the math when you treat me. So if you plan to go in that space, try to learn to code, try to learn the foundations and the basics. In human nature, we'll be looking for the easy things. So I easily would go also this way, because those algorithms are at least 10 times better than I would ever be in my own job. I thought I would say about superintelligence. I'm giving you a clue now here, and open source. So can you guess what this is? Anyone? The open source guy? No? It's a timeline of images, no? Images generated by AI. Agree with me or disagree? Agree. Okay. So they get better with the time, we get better with the algorithms, and we put more information into the pixel, and further on, you even design a prompt, and you don't have to even code anymore. It's just getting better and better with the granularity and the accuracy of the algorithm. Timeline of images generated by AI. What is this then? Guesses? A what? I can't hear you, so. Oh, no. It's also a timeline of images generated by AI. But they're not getting better, they're getting worse. With each iteration of the algorithm, it's getting worse. So, what is your guess here? Any guesses? Okay. So we take, I don't know, we take Francesca and we take Gabor and we put them in an MR machine. So they lie in the MR machine. And they see an image of a Deutsche Bahn train and a bear and a clock. And they think of it. So Gabor sees the bear and he thinks, oh, I see a bear with a tie, and that's it. Then diffusion model, through the MR, takes the signals of the brain and converts the signals into a guess of what Gabor is thinking of. So now I repeat. We take Gabor, we put him in an MR machine, the MR machine and the diffusion model has never seen the original images, and he thinks of it. Then the algorithm takes the motion and the signals from the brain and converts this into an image by guessing what he's thinking of. I'm not an MR expert. I'm not a trial expert. I'm a fake scientist, as I said. So I can understand the math in this open source paper, and I can say the math is correct. So 20% of the paper is correct. The rest I don't understand. But even if I don't understand, someone else right now is trying to crack the numbers with multiple experts in each direction. And this is what our supercomputers are currently working on, not agents. It's called mind reading. So many defense companies, many private labs are working on very similar use cases like this one. So this is my example for something that's open source, that if you have multiple experts, can go and try to build things yourself. If you have the compute, the AI factory guy will speak later on. Maybe Astria also get some compute to do that. And then you can try yourself. Okay, networks. Here are a few projects and ideas of how we are using hardcore algorithms at scale to build stuff. One example on a nation state is IVF project with the most advanced healthcare system in the world in Finland, where we take data from embryos and health data and aura rings like this one, and different other parameters. We run them through different kinds of machines and simulations, and we try to guess better than the doctors what an outcome of a treatment would be. Another one, and it's not super visible here, but this is human size. So this is basically me. We've built those devices together with Carnegie Clean Energy. We took the reinforcement learning algorithms from GenAI models, and we've deployed them at the edge, which are 7 to 18 meters from the shores of the oceans, and try to change the movement of the devices based on the changes of the waves, the temperatures, the vibrations, so that we produce the maximum amount of energy. So this is basically a size of a data center. Half of this room, only computing numbers to produce energy. And then we have examples like supercomputing centers that do innovation on a country level. And the reason I have this one here is that later on you will have a talk from what Astria is trying to do in this space. So I think you should connect the dots, because I think it's very good for Astria and very good for the ecosystem of you getting access to such an environment. This is the one I mentioned. This is from Finland. I already walked you through that. And the main idea here is that every country in Europe provides IVF for free if you're under 40 years old. So what they're trying to do is that, of course, we get smarter and older and we are not having babies, especially the Finnish population. If there are any Finnish people, you would know 7% of the Finnish populations come from IVF. So they're trying to put more couples and individuals through that. And this is where you should be spending your time, not on working algorithms for defense or like some crazy stuff, but trying to move the needle on something that actually makes sense for society. Those are the type of algorithms that we have played with. The doctors didn't like the one that we cannot explain and they cannot explain for themselves. So we did something super fancy with deep learning and all of the images of embryos and sperm and everything. But of course, the more powerful the prediction rate, the less explainable they are to the experts. And we had to roll this back because, again, you work with humans and they didn't trust the algorithms. The missions I talked about, and some biases examples, because you're all practitioners here, and this is my last hands-on project, so I feel it's like my baby, is that we had so much missing data, and I'll tell you what was the interesting part about the missing data. So Finland had the biggest data set of IVF treatments for the last 30 years, and 14% of this missing data, the whole 40% of this data that's missing was the male data. Why? Because generally infertility treatments are linked to females. So the operating staff of the hospital felt like not really interested collecting the data in the form of the males. So all of the data that was missing was males. But actually 25% of IVF treatments and the need for those come from male reasons. So what we change with this project is now staff actually has to collect all of the biometer factors of males as well. An example for bias. I mentioned this one. The coolest part here is that you have GenAI, slice the GenAI model deployed at the edge and trying to change the behavior of this machine so that you can produce maximum energy. And it's a very good example of complex AI in the middle of the ocean. So, couple of summaries to link this to sovereign AI for Europe, for the countries we represent within Europe. If you are a scientist or researcher on SME and within your country, university or company, because I have those expectations also from companies, and you cannot get access to a computing power that can consume your algorithms for less than a day, then that's not a strategy, and maybe you should rethink your company choice or country choice. We all need governance. I'm very supportive of the EU AI Act. I think people keep saying how regulated EU is, and I keep asking, show me how has regulation tightened your neck, and what is stopping you to take any open source paper and go and try to compete. We don't solve problems with a lot of money in Europe. That's okay, but we are trying our best with optimal resources. And then we trained a model. It's great if it's not replicatable with data, with talent, with local talent, and it has a specific application. It basically means nothing. So try to push the boundaries of first working with more than a CSV file and statistics to something hardcore and refer to any ChatGPT like I do or similar. And we have X GPUs because I come from the GPU world where, again, all of those algorithms run on parallel computing, which are large-scale systems, and you have to land them on those machines. It's useless without energy, interconnect, and utilization. And basically, if you think of choosing the right country based on just these statements, we all need to move to Norway, because that's the only country that has currently the energy to do any AI work in competitive levels. So I'm more or less on time. I think better than you. I tried. But thank you, and let me know if we have time for questions.